Good day, everyone. So, for this video, I would like to discuss to you the BJT amplifier or bipolar junction transistors amplifiers. Okay, so in your previous experiment, nandun yung makikita natin dito yung ah, simulations ng ating BJT. Okay? So, in this discussion, mas maintindihan natin kung ano yung nangyari sa ating experiment. So, simulan na natin. Share ko lang yung aking screen and then um, patayin ko na lang yung video ko para hindi matabunan ng mukha ko yung ilang part na, ng PowerPoint natin presentation. Okay. Okay, so this is the BJT amplifiers. So sa ating BJT amplifiers or amplifying or amplification is one of the mode of operation ng ating BJT. So last discussion natin, so doon natin diniscuss yung another two, yung switching, the saturation, and the cutoff. Ano? So, an amplifier operation, so actually, of course, proper biasing lang yung kailangan natin para tayo mag-amplify tayo o mag-act siya as amplifier. So, again, the biasing of a transistor is purely a DC operations. Okay? But guys, in this video, pupunta na tayo sa AC analysis. So, what is the purpose of that biasing? So, the purpose of that biasing is to establish a Q point. Again, Q point is the quiescent point or the operational point. So, about which variation in current and voltage can occur in response to an AC input signals. Okay? So in applications where small signals voltages must be amplified. So yung maliliit na signals natin ay palalakihin natin. That is the purpose of amplifier. So amplified. Such as, so saan natin ginagamit? Sa antenna or microphone. Okay, kaya nga, pag tayo po ay may mga sound system, so automatic yon. Before ka pumunta, yung sound natin bago pumunta sa speaker, kailangan natin amplifier. Okay? Minsan, magkasama na si amplifier and speaker sa isang box. Pero usual, hindi siya magkasama. As in, meron siyang tinatawag nating amplifier. And also, dun the amplifier, makikita natin yung mga bass, treble, etc. Ayan, then yun yung ina-operate ng ating mga ng ating mga operator, ng sound system operator natin. Okay? Excuse me. So, amplifiers design. So, bakit tayo gumagawa ng amplifier? So, to handle these small AC signals are often referred to as small signal amplifier. So, amplifiers yung nagpapalaki ng amplitude. Okay, o yung AC signals natin ay palalakihin natin o AC voltages natin. Okay. So, actually guys, we have AC quantities. So, yung mga AC quantities natin, just like meron tayong VC. So, di ba may VC tayo sa DC quantities natin? Meron siyang AC, this is a collector voltage. So, meron din tayong AC collector voltage. So, medyo ganito yung kanyang pagkakasulat. So, kung caps lock yung ating capitalize yung ating pag DC, so, malilit lang na yung AC natin. And then, medyo naka-italic ng bahagya yung ating notation for mga AC natin. So, parahan lang siya. Meron din siyang VCE. Ayan. Meron tayong IC. Yan, IC na nakatagilid siya. IE. Kompleto din siya. Meron din tayong IB. Yan. Meron tayong VC, VCE, at pang AC. Okay? So, and from which, yung pinakamahalagang quantity na meron tayo is yung tinatawag nating AC emitter resistance. So, yung AC emitter resistance ay matatagpuan sa pagitan ng ating base and emitter. So, yung ating internal AC resistance, ibig sabihin, nasa loob siya. So, this RE prime, so yung internal AC resistance natin, ganito siya isulat, RE prime, very small resistance lang ito. Okay. So, yan. So, of course, resistance siya. So, it is opposed. So, malalaman natin mamaya kung ano yung ino-oppose niya, kung anong current ang ino-oppose niya. Okay? So, ganyan po yung, ayan yung mga examples ng ating AC quantities. Pero madami pa siya. Madami pa siya. So, kung madami ang DC quantities, so medyo ganun din kadami ang ating AC quantities. Okay? So, for linear amplifier, so linear amplifier provides amplification of signal without any distortion. So, wala daw hadlang, ano? So that the output signals in exact amplified replica of the input signal. So, for example, ganito yung signal na pumasok. So, yung amplifier daw natin, o yung linear amplifier din natin, palalakihin din natin na version lang yan. Okay? So, exact replica. Okay? So, yun ang ibig sabihin ng linear amplifier. So, kung natatandaan natin, nung DC, nung tayo ay nasa introduction ng BJT, so one of the biasing technique or the most stable biasing technique is the excuse me, the voltage divider bias. Okay? So, yung voltage divider bias transistor with a sinusoidal AC source capacitively. Okay? So, mamaya malalaman natin kung ano ibig sabihin ba ng coupled and ngayon, pwede naman lang ngayon na. So, meron tayong tinatawag na coupling capacitors. Coupling capacitors and bypass capacitors. Okay? Bypass capacitors. So, ano yung ginagawa na coupling capacitors? Okay? So, yung coupling capacitors natin, binablock niya ang DC. Yung mga DC signals natin. Okay? So, ibablock ni coupling capacitors yung ating mga DC signals. And ang i-allow niya ay mga AC signals. Yun yung coupling capacitors. Yung mga coupling capacitors natin, guys, makikita siya sa input at sa output. Okay? And yung nag-iisa, so, di ba, base, emitter, collector. For example, ang ating ang ating input at saka output ay nasa base, then collector. Therefore, yung input ay yung ating emitter resistance, nandun, kakabit niya o nakaparallel sa kanya si bypass capacitor. Ang inaalaw naman niya ay si DC. Okay, yun yung bypass capacitor. So, for example, ito yung resistance natin, nakaparallel sa kanya si capacitor. And then ito yung coupled and bypass capacitor. So, depende lang sa kanyang sa kung saan siya naka-parallel. Okay? So, kung nasa input-output siya, coupling capacitor siya, so, ibig sabihin, binablock niya ang DC. Ang naalaw niya ay AC signals to amplified or for amplifications. Okay? So, ganun po yung ating gagawin. Okay? So, punta tayo sa mga transistors AC models natin o ilan sa mga R parameters natin. Okay, so kung meron tayo sa DC na alpha beta, meron din tayo dito. Also, same lang siya. IC over IE, IC over IB. But ito ay mga AC quantities ang ating kukuhanin. So, kaya tayo ay may alpha AC at beta AC. Dati, meron tayong alpha DC at saka beta DC. So, mostly naman ay magkapareho ang value ni beta AC and beta DC. So, binibigay naman siya sa given or minsan pinahanap siya. Okay? So, kaya natin kuhanin yun. Ano? So, next is the internal remittances, internal resistances. Okay? So, we have the RE prime, RB prime, and RC prime. And the most popular na R parameters is the RA prime. Yun, madami pong role yan. Madaming role yung ating RA prime. Ayan. Okay? So, yun po ating makakatandaan. Okay? So, what is the R parameters? Kanina pa tayo nagsasalita ka na yung mga RA prime, RB prime, RC prime. So, R parameter model for a BJT. So, ito po yun. So, yung table 6.1. Okay? So, ano ba yung effect ng ating RB prime? So, dito sa RB prime. So, yung RB prime, yung effect niyan is usually small enough to neglect. So, it can be replaced by a short. So, parang wala lang, ano. So, parang is pwede natin i-short na lang siya or parang gawin lang natin siyang wire o kable. Okay? Then yung RC prime naman, so usually mataas siya. So 100 kilo ohms and yung RC prime naman ay ang usual niya is ino-open. Okay? So ano naman yung RE prime? So usually yung RE prime, sabi ko kanina, naka-place siya sa emitter and base terminals. So, emitter and base. So, this is the resistance seen looking into the emitter of a forward bias transistor. Okay? So, yan po yan. So, paano determine natin yung RA prime by a formula? Okay? So, sabi ko nga kanina, yun yung pinakamahalaga. So, alamin natin kung paano siya gumagawa. Okay? So, ito pala, nandito yung ating mga models. Ano? This REC prime, RB prime, and RE prime. Okay, we have the alpha AC and beta AC IB here. Okay? So, yung RE prime natin, so, para makuha lang yung, simple lang yung RE prime natin. So, yung RP prime natin, okay, is yung ating, ano yung ating, ano yung ating VE? VE over IE yan, di ba? RE nga yan. So, of course, voltage over current lang yan. So, ano yung default natin na AC emitter voltage pagdating sa at 20 degrees Celsius at sa room. Kasi 'di ba, ang mga transistor is temperature dependent and sa ambient temperature natin which is 20 degrees, ang ating V is 25 MB. So millivolts over natin kay IE. Ito yung magiging formula natin for RE prime. Ibig sabihin, kailangan lang natin makakuha ng IE. Guys, DC ito ha, DC. Sorry, it's DC. DC po yung kakahanin natin para magsimula tayo sa RE prime which is AC. And guys, minsan sa mga ibang references siguro, na mababasa nyo, baka magtaka kayo. Minsan ang ginagamit nila ay 26 MB. Okay, so pero dito sa atin, so mag-stick na lang tayo sa 25 MB. Okay, so yun po yung ating pagkuha ng RE prime. So let's have this one. Okay, so determine natin yung RE prime of a transistor that is operating with a DC emitter current of 2 milliampere. Ano? So we have the RE prime of 25 MB over, ano yung IE natin? So 2 milliampere. So therefore, we have 12.5 milli, 12.5 ohms. So very little lang yung ating RE prime. Ay, RE prime. R yung ating internal AC emitter resistance. Okay? So aside from R parameters, so we also have H parameters. So for our H parameters, we have HI, HR, HF, HO. So siya ay ano lang, impedances. Okay? So impedances and admittance. So pag HI, so yung HI natin, input impedance or resistance. So condition niya, so usually siya ay, ang output niya ay shorted. So yung HR natin, voltage feedback ratio, so usually input niya ay ino-open natin. So HF, forward current gain or yung IC over IE natin, di ba? So IC over, yes, it's IC over IE, ano? So output shorted siya. And HO, so we have output admittance or conductance input, open din siya. So configuration for committing sa H parameters, so we have Common-Emitter. So HIE, HRE, HFE, HOE. So parang lalagyan lang natin yung E, B, and C, yung ating mga parameters, kung ano pong configuration ang meron tayo sa ating transistor. Okay? Kung emitter siya, base or common conductor. Okay? So, let's start with the common-emitter amplifier. So, yung common-emitter amplifier is one of the mas ginagamit natin o yung usual na ginagamit natin for an amplifier. So, yung common-emitter amplifier. So, ano ba yung mga characteristics ng isang common-emitter amplifier? So, this figure or this schematic shows the common-emitter amplifier with a voltage divider bias. Okay, so voltage divider bias. Okay, so and also makikita natin, so ang input natin is here. Okay, so ang input natin is here and output natin is nasa base tayo and then nasa collector yung ating output. Therefore, itong ating C1 at saka yung ating C3, ay palitan ko nga yung aking color ng pointer. Yung color. Let's say, gawin natin blue. Yeah. Okay. Ito yung ating gagawing coupling capacitors. Again, ano ang ginagawa ng ating coupling capacitors? So, coupling capacitors ay block DC and allows AC. So, yung AC signals po ang ating i-amplified. So, yung C2 natin is the bypass capacitor natin. So, yung input signals natin, again, nasa yung VE natin or input signal, so input voltage is capacitively coupled to the base terminal. Okay? The output signals naman is capacitively coupled from the collector to, so collector to load natin. Okay? So we can see that the amplified output voltage is 180 output out of phase. So, di ba? Pag ganito siya, and in-amplified natin, pero bumaliktad siya. Kaya siya ay 180 degrees out of phase. Okay? So, yun pang ibig sabihin na. So, bakit siya nag 180 degrees? So, because the AC signals is applied to the base terminal as the input and taken from the collector terminal as the output. Okay? So, the emitter is common to both the input and output signals. So, guys, mapapansin natin dito that there is no signal at the emitter because, bakit? Kasi nga, the bypass capacitor effectively shorts the emitter. So, i-short niya siya. So, di ba? Ang ina-allow niya naman dito is DC. So, wala siyang, binablock niya naman si, di ba yun ang role ni bypass? Ibablock niya si AC. So, kaya siya ay, sasabi natin that there is no signal at the emitter terminals. So, sino-short. So, yung bypass capacitor, sino-short niya yung emitter to ground at the signal frequency. Okay? So, all amplifiers have a common combinations of AC and DC operation. So, mamaya, nagko-compute tayo ng DC and AC quantities natin. Okay, but keep in mind that common emitter designation refers to the AC operations. Okay, so how about the base phase version? So yung output signal natin, which is sabi ko nga kanina, is 180 degrees out of phase with the input signal. So as the input signal voltage changes, it causes the AC base current to change. Okay? So, of course, so basta magbago yung ating input signals, yung AC base natin o yung IB natin ay magbabago din. So, it also resulting in the collector current to change of course, to change also from its Q point value, quiescent point value natin. So, it indicates that, or it causes to that if the base current increases, so kung tumaas daw si IB natin, so the collector current increases above, so also yung ating IC ay tataas din kasi nga siya ay directly proportional si IB and si IC by beta natin. Yung beta natin yung kanyang proportionality constant. So, it's also increasing from the Q point value natin. Ano? So, it causes to increase also the voltage drop across the RC. So, kung tumataas yung current natin, tumataas of course yung ating voltage drop. Okay? So, this increase in the voltage across RC means that the voltage of the collector decreases from its Q point. So, and change in the input signals voltage results in opposite change in collector signal voltage, which is phase inversion. Ano? Okay, so punta naman tayo sa DC analysis natin. So, pag DC analysis natin, ito lang yung titingnan natin. Okay. So, this one. Okay? So, parang yung ginagawa natin ng una, DC analysis. So, pupahanin pa natin siya. So, again, pupuhanin muna natin si RTH. So, yung RTH natin is yung ating R2 over parallel sorry. So, R1, parallel natin kay R2. Ay, what's wrong? So, parallel, napindot ko pala yung R stop share. R2 over R1 plus R2. Times pala to kasi parallel R2. So, multiply natin 6.8 kilo ohms times 22 kilo ohms. Then, pag-plusin natin siya, 6.8 kilo ohms plus 22 kilo ohms. So, makakakuha tayo dito ng 5.19 kilo ohms. Okay, so for RTH. For our VTH naman, we have the R2 over R1 plus R2. R2 times natin si BCC natin, which is 12 volts. Okay. So BCC. Okay, so we have here 6.8 kilo ohms over 6.8 kilo ohms plus 22 pala. So 22 kilo ohms times natin kay 12 volts. So makakakuha tayo dito ng 2.83 watts. Okay? And then, kasi ang goal nga natin dito, di ba, kumuha tayo ng IE. So, kuhanin natin ng IE para makakuha tayo ng RE prime. So, yung IE natin, so, kuhanin muna natin si IB para makakuha tayo ng IC para makakuha tayo ng IE. Okay, so, si IB ay equals kay, or so, shortcutin na lang natin, VTH minus VBE over 50 so 50 so diretsuhin na lang pala natin, no, para wag natin dumaan sa IB. So since ito na ganito na, tapos wala na ito, tapos VTH na lang ito, so voltage divider bias na lang tayo, mag KVL na lang tayo dito. So we have the VTH minus the IB RTH minus VBE minus VE RE natin. Si VE natin or si IE RE natin. Ano? Yan. So, assume natin that IE is approximately equal to IC. And then si IC natin is beta IB natin, diba? So, beta IB. So, therefore, si VTH natin minus. So, lagyan natin ito. So, VTH equals kay. So, ang kakailangan natin is si IE. So, itong IB ay equals kay IC over beta, which is IE over beta. So, si IB natin is equals to IE over beta. Then RTH minus BBE minus IERE is equal to 0. Again. So, therefore, we have IE equals natin kay VTH minus BBE over natin kay RE plus si RTH over beta. Ano? So, yun natin magiging formula. So, kuhanin lang natin. Si VTH natin ay equals kay 2.83 volts minus natin kay 0.7 na BBE over yung RE natin, which is ito, 560 minus yung RTH natin is 5.19 kilo ohm na i-divide natin kay beta, which is 150. Okay, so yan po yung ating IE. And ang makukuha nating IE is 3.58 milliampere. So this is also equal to our IC. Okay. So pag makuha natin yung mismo VE natin, so VE natin is IE RE. So si 3.58 milliamperes ay mo-multiply natin kay 560. Okay, so 560 and kakakuha tayo dito ng 2 watts. Okay, so yan yung mga important basic quantities na kukuhanin natin. So kuhanin na rin natin si BB. So yung BB natin is VE pang pabuhat dito sa BBE, papantad dito, pabuhat dito, pag ganun. So, BBE, VB minus VBE, sige na nga. So, VB minus VBE minus VE is equal to 0. Therefore, si BB ay equals kay 0.7 plus yung BE natin, which is 2 volts. So, therefore, we have 2.7 volts na BB. Okay? So, parang pwede din natin kuhanin. I think, yung kuhanin natin yung IB, then multiply natin kay RTH, and that is also the BB. So, for our BC, so, of course, yan ay VCC minus ICRC equals to BC. So, VCC minus ICRC. Okay, so, equals siya kay 12 volts minus 3.58 milliamperes na times natin kay RC natin, which is 1 kilo, 1.0 kilo. So, ito makukuha natin dito is 8.43 or 42 volts. Okay? So, meron tayong VB, VC, meron tayong BE, and isa pa sa pinaka-importante, so, hindi ko na alam kung saan susunod, dito na lang, yung ating BCE, di ba? So, sa cut-off and saturation, lagi siyang bida itong BCE na ito. Di ko alam natin, ano? So, BCE, so, of course, BC minus VEN. So, 8.42 volts minus yung ating VE, which is 2 volts. Therefore, we have 6.32 volts. And that is our DC quantities. Okay, pag sinabi kong find all the DC quantities na meron tayo, so yan yung makukuhanin natin. Okay? So, punta tayo sa AC analysis. So, for our AC analysis, so, meron tayong mga steps na susundin. Okay? To analyze, excuse me, yung ating AC signal operation of amplifiers. So, an AC equivalent circuit is developed kung paano ito nagawa. Ito yung example of AC equivalent circuit. So, it developed as follows. Una, yung number 1 natin. Yung capacitors daw natin, yung C1, C2, and C3 natin kanina. So, punta ulit tayo. Ito daw, C1, C2, and C3. Gagawin natin muna daw siyang short lahat. Yan. So, pag sinort natin yan, gagawin natin short or wired lang siya. Wired. Okay? So, i-replace natin siya ng wide. So, because their values are selected to, because their values are selected so that XC is negligible. Okay, yung imaginary part natin. at the signal frequency and can be considered to be also almost zero yung ating um, um, resistance, yung imaginary part natin, the XC. And also, lahat ng DC sources, lahat ng ating DC sources, yung BCC, ay gagawin nating ground. Kung may BBB band din tayo, kung may BBB na tayo, so, i-ground din natin siya. Okay? And then, ipaparal-paral lang natin. Ano? So, kapag nag-ground ito, so, itong R1, so, para nakaparal na siya kay R2, so, magiging ganito na siya. Ano? Okay? So, tapos itong RC natin, so wala na yun, para nakaparala lang din siya dito. Parang ilalawit lang natin siya dito. Okay? So, ito, 0, 0. So, ito mawawala na ito, di ba? Yung RA prime natin, wala siyang AC. So, tanggal natin yung RA natin. Ano? So, ganun lang siya. So, kaya, ganito yung nangyari. So, kung itong letter A is without input signal. So, wala tayong input signal dito sa base region. So, yung AC grounds natin, so, colored siya ng green. Pero, hindi ko naman kailangan na ibahin ko yung kulay ng ground kapag tayo nag-solve. So, okay lang na lahat siya ay black in color. Okay? So, ganyan yung ginagawin natin kanina. So, kapag may AC source tayo, so, VS at saka RS. So, kung makitatandaan nyo yung source transformation, so parang ganito yun. Meron tayong IS. Okay? O yung IB natin. So, BS, so voltage source natin or AC voltage source. And meron tayong RS dito. Okay? So, represents the resistance natin sa input. Ano? So, ganyan. Which is nakaparallel lang din naman. So, R2 nakaparallel kay R1. So, yung R1 and R2 natin na yung magiging sagot natin as parallel, nakaparallel pa ulit siya kay RS. So, ganun yung mangyayari dito. Ano? So, ganyan maggawa ng AC analysis natin. So, may mga computation naman, may formulas na meron tayong pupahanin for AC analysis natin. So, maya-maya, so, ito. So, mamaya mga R input na yon pukahan natin. Okay? So, in AC analysis, those AC ground and the actual ground are treated as the same point of electrically. Same point electrically. So, pare-pareho lang siya. Saka ground yung AC ground and actual ground. O yung mga AC ground, di ba? Yun yung mga source natin. Ano? So, di ba, kung mapapansin nyo, yung ating pinagkuhanin itong AC analysis is Common-Emitter. So, because the bypass nga kanina, capacitor natin. Guys, kung nasaan po yung bypass capacitor, yun po yung kanyang common o yung kanyang configuration niya. Since nasa emitter yung bypass capacitor natin, nandun yung kanyang, yun yung siya ay common-emitter. Okay? So, and the common point ng lahat ng yan is our ground. Okay? So, an AC voltage source o yung VS natin, di ba? Naglagay tayo dito ng VS. So, ano naman yan? So, it shows, it's shown connected to the input. If the terminal, so ano yung mangyayari? If the internal resistance of the AC source is 0 ohm, then all of the source voltage appears as at the base terminal. If, however, the AC source has a non-zero internal resistance, then 3 factors must be taken into account. So, ano-ano yung mga factors to be taken into account. So, in determining the actual signal voltage at the base. Okay. So, yung una natin, so yung RS natin, yung bias voltage na bias resistance natin. Pag sinatin na bias resistance, yun yung R1 and R2 na nakaparallel kasi siya ay di ba siya ay voltage divider bias. Yun yung RTH natin. Okay, so pangalanan natin yung bias resistance as RTH. And also, yung ating AC input resistance. So, yung AC input resistance natin is R in base na tinatawag natin. Di ba may R in base na tayo nung una? So, yung combination siya ng simplified by combining R1 and R2 and R in yun, yung R in base natin siya. Okay? So, yung R in base natin is may formula siya nung tayo ay nag-DDC. So, yung AC input, AC input resistance, hindi pala ito yung R in base. R in total. So, R in total. Okay? So, yung R in base, nandito yung R in base. Yan. May computation yan. So, yung combination nitong tatlo, yun yung R in total. No? So, hindi kasama itong RS. Ito lang. Yan. Yung R1, R2, at saka yung R in base. So, pag pinakalal natin silang tatlo, yun yung R in total. Yun yung pang looking back resistor. Yun yung R in total natin. So, yan. So, total input resistance or R in total natin. Okay. Ito pala yun. Yung pinagsasabi ko. So, you have the base. So, R in base yun. So, parang nagkaroon tayo ng imaginary dun sa, nagdagdag tayo ng isang resistance which is R in base. So, yung R in base na ito, diba sabi ko kanina may formula yan. So, yung R in base na yan is, ang formula niyan is yung ating beta AC RE prime. Okay, so yun yung R in base natin. So, paano siya makukuha? So, of course, makakukuha naman tayo ng RE prime. So, 25 MB over IE natin. Kukuhanin lang natin yung ating IE. Okay? So, for example, so nagkaroon na tayo na ito ng RS, R1, R2, tapos makakompute na tayong R base. So, pwede na tayo makakuha ng R in total. So, ipaparallel lang natin yung tatlo. Okay? So, meron tayong RE total, and then, pwede na natin itong pagsamahin para makakuha tayo ng VB. So, pag nag-VB tayo, so, voltage divider lang siya. Okay, so, voltage divider natin, yung para makakuha tayo ng base voltage, AC base voltage. So, ang formula natin for this is, so, ang kukuhanan natin is R in total, R in tot, over yung RS natin, plus R in tot. Sorry. So, R in tot natin. Times natin yung VS natin. Okay? Usually, guys, mababa lang yung voltage ng pag mga AC natin. So, mabababa yung VS natin and VB na nakukuha natin. Okay? So, ganyan lang. Ganyan lang po yung ating mga formulas na gagamitin. So, example tayo. So, determine the signal voltage at the base of the transistor. So, in figure below, 6.13, the circuit is the AC equivalent of the amplifier in figure 6.8 with a 10 millivolts RMS, 300 ohm na RS. So, di ba sabi ko sa inyo, ma-hit lang yung mga VS, 10 MV lang. And source, so IE was previously found to 380. Okay, so ito yung kanina nating kihanahanan ng DC circuit. So, kung matatandaan nyo, solve na tayo mga DC. So, check natin kung ano yung IE natin nakuha kanina. Kasi para diretso na tayo sa RA prime. So, ang IE natin kanina nakuha ay 3.58. I'm sorry. Tama ba? Sorry. Binigyan lang pala tayo dito ng given. So, ISIA is found to be 3.80. Hindi na ginamit yung kaninang 3.58 milliampere. So, sige. Since ito yung binigay sa ating problem, is 3.80. Okay? So, baka nag-round off lang siya. Kaya naging 3.80 milliampere. Pero yung sa atin is 3.58. Sige na, 3.80 na. Kasi ito yung given natin. Pero try nyo din, baka kung gusto nyo yung 3.58. Okay. So, since may I na tayo na 3.80, so we have 25 MB over yung I natin which is 3.80 milliamperes. And this would be 6.58 ohms. So, ito yung ating RA prime. Okay. So, pag meron tayong RA prime, makakakuha na tayo ng R in base. Paano? Kasi, di ba, ang R in base ay equals lang siya kay beta AC RE prime, which is 116 beta natin times 6.58 ohms. And that is 1.05 kilo ohms. Okay, yun yung Rn base natin. Pag may Rn base tayo, tapos may R1, R2 tayo dito, so makakakuha tayo ng R in total. So, yung R in total natin, parallel siya kay, parallel R1, parallel kay R2, nakaparallel kay R in base. Okay, so 1 over, ang R1 natin, 22 kilo ohm, plus 1 over 6.8 kilo ohm, plus 1 over 1.05 kilo ohm. So, 1 over lang lahat ng yon. So, wait lang. So, 1 over 120, 1 over 1 over 22 kilo ohm, plus 1 over 6.8 kilo ohm, plus 1.05 kilo ohm. So, makakakuha tayo na 873 ohms na R in total. So, ano sunod natin kukuhanin? Yung ating VB. So, yung VB natin. So, ano ba hinahanap natin? Determine the signal voltage across the base. So, yung VB nga natin ang kinukuha. So, R in tot over RS plus R in tot. So, we have 873 ohms over R in tot natin is RS natin is 300 plus Rn total natin is 873. So therefore, multiplied by 10 millivolts natin Vs natin. Times pala ito kay Vs. So equals nan, pag nakakuha tayo ng 873 over 300 plus 873, so equals kay 7.44 millivolts. Okay, so yan po yung ating magiging answer. Okay? So, yan lang po. So, yun yung ating naging examples. Next natin is the voltage gain. Okay? So, kung meron tayong voltage gain nung DC, meron din tayo dito. Of course, same lang din. So, kung AV natin is out voltage over input voltage. So, VC over VB. Okay? So, assume that VAC is equal to alpha AC IE RC. Yeah. So, actually, BAC. Sige na, para alam natin na DC, AC and DC, So, AC is equal to IERC. So, kasi approximate to 1 lang naman yung alpha din dito, di ba? And yung BB natin is IA RE prime So, since VC over VB, so pag natin siya, IA, cancel natin yung IA, alam natin na si AB ay equals kay RC over RA prime. So, ito lang yung voltage gain natin. Ano? So, bakit kaya ako? Ang tanong ko ay bakit ako dito sumiksik? Lawak-lawak dito na para mag-solve natin. So, guys, kung tayo may voltage gain na pinag-uusapan, ano naman yung kabaliktaran ng voltage gain? So, ang kabaliktaran ng voltage gain is the attenuation. So, ano yung attenuation naman? Ayan, attenuation. So, kung attenuation is kabaliktaran lang ng gain. So, kung gain ay padagdag, so attenuation is the reduction. Reduction in signal voltage, as it passes through a circuit. Okay, so and corresponds to a gain of less than 1. Okay, so kabaliktaran siya ng gain yung attenuation. For example, if the signal amplitude daw ay bumaba ng kalahati or reduced by half, so the attenuation is nag-twice naman siya. Kung nag-reduce siya ng kalahati, nagtaas naman ang attenuation ng dalawa. So, increases by 2. Ano? So, which can be expressed as a gain of 0.5 because the gain is the reciprocal of attenuation. So, suppose daw natin that meron tayong 10 MB kanina, di ba? Doon sa example natin, we have the 10 MB input signals and the source resistance combined with the load resistance results at 2 MB output, di ba? So, yun na yung nakuha natin. So, in that case, so yung attenuation natin ay output over input. So, ito yun yung gain niya. Therefore, yung magiging input magiging attenuation natin is yung 10 NB o input over output, which is 10 MB over, so, sana sinusulat mo sir. Sige, yung attenuation, so yan na lang. Hindi ko kasi alam yung yung symbol for attenuation. Okay, so at na lang siya. So, BB na siya over VC. So, yung 10 MB over 2 MB, magiging 5 na lang siya. So, 5 yung ating attenuation. And yung ating voltage gain is 1 over 5 or 0.2. Okay? So, yan naman po yung katulad nito. So, yung over voltage gain natin, we have the VC over VS. So, yung attenuation natin is VS over VB. So, kung gain natin, so B over VS siya. Okay. Yung voltage gain natin sa base to collector, so base to collector, so BC over BB. Gain siya kasi output over input. Okay, so attenuation ng source to BB, so to the base, so VS over BB. Kung gain natin siya, BB over VS. Overall gain, so BC over VS. So ating attenuation is VS over VC. So ganun lang po yung ating. Okay. So tingnan naman natin yung effect of the emitter bypass capacitor sa voltage gain, di ba? Kasi yung bypass capacitor, pag di ba sino-short lang natin siya. So yung emitter bypass capacitor natin, which is C2, doon sa kanina pa natin pinag-uusapang circuit. Ayan, ito yung C2 capacitor. Okay. So, it provides an effective short to AC signal. So, sino-short natin around the emitter resistor. So, thus keeping yung ating the emitter at AC ground. So, with that bypass capacitor, the gain of a given amplifier is maximum to and equal to. So, ang atin daw gain is as a maximum to RC over RE prime. So, that the value of that bypass capacitor must be large enough so that its reactance over the frequency range of the amplifier is very small. So, ideally, yung ating reactance is 0 ohm. So, compared to RE. So, a good rule of thumb is that the capacitive reactance XC of a bypass capacitor should be at least 10 times RE. So, titingnan natin, check natin that 10XC is equal or greater than sa ating RE. So, check lang natin siya. Okay? So, example tayo. So, yung example natin, select a minimum value of for the emitter bypass capacitor C2 in figure below. If the amplifier must operate over a frequency range from 200 Hz to 10 kilo. So, C1, yan din yung kanina natin. So, pahanin natin yung XC. So, yung XC natin is, check natin, should be at least 10 times daw, di ba? So, therefore, yung XC2 natin is RE over 10. So, XC natin, which is 560 over 10. Therefore, yung XC2 natin is 56 ohms. At least equal, di ba? At least equal. So, yung capacitor natin, makukuha natin siya by 1 over 2 pi F C2. Okay? So, XC2 to. So, we have C2 of 1 over 2 times yung 2 times pi, 2 pi natin, times yung frequency range natin, which is 200 for minimum, times yung ating XC2 na 56. And this would be equal to 114.2 microfarad. Okay, so this is the minimum value for the bypass capacitor for this circuit. Okay, so yun yung minimum value natin. So you can always use a larger value. All the cost and physical size may cost limitation. Okay? Limitation. Okay? So, ibig sabihin, ito yung pinakamababa o minimum value na pwede nating ilagay dyan to operate properly. Okay? So, next. So, yung voltage gain natin without the bypass capacitor. So, anong meron kapag anong mangyayari sa voltage gain natin kapag walang bypass capacitor? Kasi minsan, kung pwede kasing wala na lang yun, Kasi sino-short din naman natin. So, yung magiging formula natin, so instead na RE is seen by the AC signal between the emitter and ground effectively. So, effectively, add natin yung ating RE prime. So, therefore, yung AB natin, so sa halip na siya RC over RE prime, magti-take effect yung ating RE kasi wala nang dahilan. Kung wala yung capacitor, ayan, kung wala nang capacitor, so wala nang magkokos sa kanya to make it short. Para mag-short yung ating emitter resistance. Kaya siya magiging RE prime plus RE, naka-series na siya. Okay? So, dito, calculate the base to collector voltage gain of the amplifier both without and with an emitter bypass. There is no load. So, doon sa 6.16, so, ang RA prime natin kanina is 6.58. Yung, kasi nyo kinopute natin, ano, ito nga ba yun? Saan ba tayo kumuha kanina ng RA prime? Ito, yung RA prime, 6.58. And then we have RE natin dito. Ang RE natin dito is 560. Okay? And ang RC natin is 1 kilo. Okay? 560 tapos 6.58 ohms. So RC of 1.0 kilo ohms, RE of 560. So yung AB natin is RC over 560 plus 6.58. So we have makakakuha tayo na approximately equal to 1.76 na voltage gain. Okay. So yun ay kapag may pag yan ay walang C2. Okay? Kasi hindi siya mag-short yung RE natin. So kapag wala naman, kapag with, so ito without C2. So pag may with C2 o merong C2, so we have AB lang is RC over RE. So RE. So we have 1 kilo ohm over 6.58 ohms, which is equal to 152 the voltage. Okay, so kitang-kita natin kung ano yung iba o yung naging effect ng bypass capacitor. Okay, so mas mataas ang gain na meron tayo kay with C2. Okay, so next nating tingnan ay kung ano naman yung effect ng load sa voltage gain kapag may RL. So, kapag may RL, so itingala natin tong ground, itingala natin doon. Ayan. So, nakaparallel si RL kay RC kung makikita natin. Ano? Therefore, yung RC na mali na AC is the parallel of RL and RC. Okay, so yun yung magiging effect ng dalawa. Therefore, so replacing RC, yung RC na malaki, or DC, so yung AB natin is yung RC na, or over RE prime, or ito yung RL over parallel to RC over RE prime. So, yun yung mangyayari. Ano? So, yan. So, again, ganun pa rin yung ating gagamiting circuit. So, calculate the base to collector voltage gain. Then a load resistance of 5 kilo ohm is connected to the output. The emitter is effectively bypass and RE prime is 6.58 pa rin yung gagamitin natin. Kuhain muna natin yung parallel. Ano? So, RC over RL over RC plus RL. So, 1 kilo ohm times 5 kilo ohms over 1 kilo ohm plus 5 kilo. So this would be 833. So 833.33. Okay? So therefore, yung ating magiging AB of voltage gain is 833 ohms over 6.58 or RE prime. And that leads to 127 na voltage gain. Okay? tayo sa stability ng voltage gain. So, to make it stable. So, yung stability is a measure. So, is a measure of how well the amplifier maintains its design values. Parang nagme-maintenance lang tayo dito, ano? So, over changes in temperature or a transistor with a different beta. Okay? So, although bypassing RE does produce the maximum voltage gain, so, di ba, no? Pag binabypass natin yung RE, so, mas mataas yung voltage gain niya. Kasi nawawala yung effect niya, no? So, there is a stability problem because the AC voltage gain is dependent on RE prime. Okay? So, di ba, dependent si RE prime kay, si voltage gain kay RE prime. Kasi yun lang naman yun. Kakapekto sa kanya. So, also, RE prime depends on IE and on temperature. So, this causes the gain to be unstable over changes in temperature because RE prime increases. So, pagtaas ng temperature, tumataas yung ating internal resistance. So, the gain decreases and vice versa. Okay? So, para lang siyang AV over R. Yun na lang siya. So, yung AV is equal to RC over RE. So, pag pinag-usapan natin yung stability of voltage gain. So, swamping of R prime to stabilize naman. So, yung swamping naman is the method naman used to minimize the effect of RE prime without reducing the voltage gain to its minimum value. So, i-minimize natin yung value ng RE prime, yung effect ng RE prime. Okay? So, this method swamps out the effect of RE prime. Pag tatanggalin. So, swamping is a compromise between having a bypass capacitor across RE and having no bypass. So, parang, ayan, magkaroon ng, binigyan ka ng sarili pang RE, ano? So, ganun lang po yun. Okay? So, pag ganyan na nangyari, so yung AB natin, yung voltage gain natin is RC over RE prime plus RE1. Okay? So, parang lagi siya may RE na. Okay? So, yan. Parang, meron man naka-bypass, pero at least merong RE pa rin siyang pagkukuha. Okay? So, example tayo. So, determine the voltage gain of the swamp amplifier. Assume that the bypass capacitor is negligible. So, negligible reactance for the frequency at which amplifier is operated. So, assume that ang RE prime down natin is 20 ohms. So, ganyan-ganyan ulian. Okay? So, ano yung ating pagagawin din? So, ang tinatanong lang natin, AV. No? So, RC lang tayo over RE1. We have 3.3 kilo ohm over 330 o di ang dali, 10. Diba? Parang kahirap-hirap. Ano? So, yan lang. Swamp amplifier kasi siya swamp. Pag swamp guys, may ganito at saka may ganito. Okay? So, effect daw ng swamping sa amplifier's input resistance kasi kanina lagi tayong voltage gain. Yung RN base natin, yung input resistance natin, magiging beta AC over RE prime na lang siya plus RE1 kasi nga naka-series siya. Okay? So, yun. So, current gain and power gain. So, yung current gain and power gain natin. So, before tayo, compute na natin bago tayo ang current gain. So, ang AC over AI, current gain is IC over II. Input, output over input. Okay? So, where yung IC natin, so yung IS natin ay equals kay VS over RS plus R in dot. So, yun yung ating magiging IS. And the power gain, so ano power gain? Pag multiply lang natin si AV, si voltage gain, at saka si power, si current gain. Which, pwede din natin siyang, yung overall voltage gain ay pwede natin siyang sulat as DC over VS. Okay? So, punta tayo sa wait lang, inom lang ako ha. Okay. So, solve lang tayo. Okay, so for the amplifier, 6.20. Determine daw natin si collector voltage. At determine daw natin si AC voltage. Okay. So, una natin drawing yung waveform. Okay. DC collector voltage saka AC collector voltage yung ating kukuhanin. Okay? So, of course, kuhanin muna natin yung kanyang ibang enough space. Susunod para sa AC. Ayan, meron naman pala. Okay? So, kuhanin natin yung mga DC. For DC quantities tayo. DC quantities. Ayan. So, itong part lang na ito, no? So, DC quantities. So, kinukuha natin si RTH. So, kuhanin natin si RTH which is R1 over R1, R2. So, 47 kilo ohms times 10 kilo ohms over 47 kilo ohms plus 10 kilo ohms. And makakakuha tayo ng 8.25 kilo ohms. And then, kuhanin natin ang VTH. So, yung VTH natin is 10 kilo ohms over 47K plus 10K. And that would be 1.75 volts. So, yung IE, na-determine na natin yung formula kanina nito, no? VTH minus VBE, which is 0.7 over RE, which is 470. So, 470 lang ang pareho siya, no? 470 plus 470. So, dalawa ito, 470 plus 470 kasi short muna natin siya sa DC. So, 470 plus 470 para sa IE, para sa RE, ano? RE1 plus RE2. Plus natin si ito 8.25 kilo ohm na RTH over ang ating beta. Ano yung beta natin? Ayun, beta DC ang gagamitin natin which is 150. So, makakakuha tayo ng sagot dyan na 175, 1.75 minus 0.7 over 470 plus 470 plus 8.25 kilo ohm over 150 na beta DC. So, answer is 1.06 milliamperes. Yan. And this IC is approximately equal to IE, which is 1.06 milliamperes. So, makakakuha tayo ng VE, which is IE over RE1 plus RE2, which is equal to 1.06 milliamperes times 940. So, ang sagot yan is 1 volts. So, BB naman natin. So, BB plus BBE, which is 0.7. So, yung BB natin, VE, natin is 1 minus 0.7 volts. So, therefore, we have mabibin na 0.3 volts. And we have VC. So, yan. This VC na tayo. Makakuha na tayo VC. VCC minus ICRC. So, yung ICRC natin is 10 minus 1.06 milliamperes times 4.7 kilo ohms. So, therefore, yung VC natin is 5.02. Okay, so yan ay DC collector voltage. So, how about naman kay AC collector voltage? Okay, so, meron tayo dito. So, drawing tayo, which is, meron tayong RS, na 600 ohms. 600 ohms. Tapos, meron tayong VS. Yung VS natin is 10 MV. Tapos, meron tayo dito BP. Tapos, so, yung R1 parallel kay R2, yung RTH natin, RTH na lang. Yung RTH natin is 8.25 kilo ohms. So, RE1 na lang siya kasi 'di ba magiging short na siya. Magiging short na yung RE2. Tapos we have yung RC natin, si RC para RC over RC, yung parallel na yung RC saka RL. So, pag kinumpit natin yun, so, meron tayo dito 4.7 kilo ohms. Ano nga yun? 4.7 kilo saka 47 kilo ohm. 4.47 kilo ohms. So, makakakuha tayo dito ng 4.27 kilo ohms. Okay? So, yan. Yan is AC equivalent circuit natin. So, AC equivalent circuit. Okay? So, kuhanin muna natin si RE prime, which is 25 MB over IE. So, nag-connect na si AC and si DC. So, we have 25 MB over 1.06 millivolts. So, equals to 23.6 ohms. Yan. Okay. So, Rn tot, since may Rn base na tayo. Wala pa pala tayong Rn base. So, Rn base muna kuhanin natin. So, Rn base natin. So, we have beta AC times RA prime plus RA1. So, we have, ang beta na natin na gagamitin for AC is 175. So, 175 times RA prime na 23.6 plus RA1 natin na 470. So, we have 86.5 kilo ohms. Okay, so makakakuha tayo ng R in total, which is parallel lang naman siya, no? So, 47 kilo ohms. Tama. Parallel kay 10 kilo ohms. Parallel kay 68. 86.5 kilo ohms. And then, makakakuha tayo ng 7.53 kilo ohms. Okay? So guys, baka isipin nyo kasi kung nakuha itong 47 at saka 10. Ito po yun, no? 47 saka 10 kilos. Diba si R ang total ay R1 parallel kay R2 na parallel kay R in base. Okay? So, yun po yun. So, lalagyan ko dito. R1, R2, R in base. Yan. Okay? So, hindi pa yan ang ating sagot kasi ang hinahanap sa atin ay AC na collector voltage. Of course, meron na tayong RC which is RC over RCRL over RC plus RL. So, makakakuha na tayo ng voltage gain. So, yung voltage gain natin is equal to RC over RE1. Yung RC equals to 4.27 kilo ohms equal siya kay 470 ohms. Yan. So, this should be equals to 9.09. So, 9.09 voltage gain natin. And, meron tayong overall gain, which is, diba, VB over VS yun. Sabi ko kanina, times kay AV. Yan. So, 0.93 yung sige, huwag na natin shortcut. Yung BB natin is, ano yung BB natin kanina? Ay, wala pa pala tayong BB. So, kuhanin muna natin yung attenuation. Yung attenuation natin, is equal to VS over BB. And so, parang babaliktarin lang natin yung attenuation natin. Yung BB over BS. So, yung attenuation natin is, yung VS ay equals kay RS plus R in tot. So, RS plus R in tot yung BS natin. Ano? Over yung BB natin is equal kay R in tot. Yan. So, kasi VS natin is IB times RS plus R in tot. So, BB natin IB times R in tot. So, kaya cancel yung IB pareho. So, we have here 600 plus 7.53 na R in tot. Nasa na yun? Ito, kilo ohms. Over kay 7.53 kilo ohms. Tama kukuha natin dyan is 1.08. Okay? So, ang BB over BS natin is 1 over 1.08. Yan. Times natin kay AV na 9.09. And yung overall current voltage gain natin is 8.45. Okay? Saan pa equal si AB prime? So, di ba? Si overall voltage gain equals kay VS over kay output, so VC over VS. So, makakakuha na tayo ng BC by BC is equal to A prime V times VS. If nakuha na tayo ng overall current, voltage gain, then meron tayong VS. So, pag-multiply lang natin. So, 8.45 times 10 millivolts. So, we have the VC of 8.45 millivolts. And this would be our collector, AC collector voltage. Okay, susundan nyo lang yung pattern pag tayo po ay nag-compute. Okay? So, yun po yung ating DC and so compare natin so ang DC 5.02, ang AC 8.45 millivolts. So millivolts yung meron tayo. Okay? So next tayo. Common collector amplifier naman tayo. So, kanina common-emitter. So, madali lang to kasi pare-pareho lang naman yung pinagagawa natin. Dito sa common-emitter, common amplifier, common collector, common base. So, common collector amplifier is commonly known as emitter follower. Okay, so yung common collector or CC is usually referred to as an emitter follower where the input is applied to the base. So, nasa base pa rin natin. Pero ang output natin is nasa emitter. Kaya siya naging common collector. Okay. So, coupling capacitor natin is hindi sa RC. So, doon na tayo sa kay RE at saka si RB na tayo. So, yun yung mga coupling capacitor. Ikaw, dalawa lang naman dito. So, meron na tayo. So, the voltage gain. So, yung voltage gain natin ito yung sa characteristic ng CC. So, yung voltage gain niya ay approximately equal to 1 or 1 natin siya. And its main advantages are its high input resistance and current gain. Okay? So, ayan. So, ulitin ko. So, all voltage gain ng common collector is 1. And advantage niya is high input resistance. So, mataas na input resistance at saka current gain. Okay? So, an emitter follower circuit with voltage divider bias. So, meron tayong voltage divider bias. So, notice that the input signal is capacitively coupled to the base and the output signal is capacitively coupled from the emitter. And the collector natin ay i-ground natin. I-ground natin yung ating AC ground natin, yung ating collector. Okay? So, there is no phase. Kanina sa 180 out of phase ang emitter, common emitter. Ang common collector or emitter follower is no phase inversion. So, and the output is approximately the same amplitude as the input. So, halos pareho lang yung dalawa. Okay, so ito yung ating AC equivalent circuit. Ayan. Okay? So, for the voltage gain, which is 1, so, kailangan pa ba natin computing? So, wag na, no? Since siya naman ay 1, alam na natin, lagi siyang 1. So, input resistance. So, paano natin kukumputin ng input resistance? So, yung Rn base natin. Rn base. Yung Rn base natin would be equals to beta AC RE. Okay? So, yan ating gagawin. So, same lang din yung Rin tot. Ganun-ganun din. So, ito lang yun. Sa halip na Re prime, so Re na yung ating content natin. So, for the output resistance, we have Rs over beta AC. Then, ipaparalan natin kay Re. Re na DC. So, kanina AC emitter resistance yung Re natin. Okay, so for our current gain natin, we have IE, emitter resistance, current, AC, saka yung input resistance natin, which is so yung input current natin is equals kay V in over R in top. And for our power gain naman, we have AP is equal to approximately equal to AI. Ayan. So, pwede na tayo mag-solve. Okay. So, determine the total input resistance of the emitter follower Also find the voltage gain, current gain, and power gain in terms of power delivered to the load, RLS on BAC. Beta AC is 175 and the capacitive reactance are negligible at frequency of operation. Okay? So, kuhanin natin si RE. Si RE natin ay equals kay, so, parallel. So, RE ay parallel ng RE and RL. So, we have 470 times 470 over 470 plus 470, and that would be equals to 235. O parang i-divide lang natin sa 2. Okay? And then for our Rn base, sorry. So yung Rn base natin, so beta AC times Re, which is 175 times 235 is equal to 41.1 kilo ohms. Yan. Tapos, Rin tot natin is R1 parallel to R2 parallel to Rn base. Ay, ano ba yan? Rn base. So, equals kay 1 over 18 kilo ohms plus 1 over 51 kilo ohms plus 1 over 41.1 kilo ohms. And that would be equals to 1 over 1.18 plus 1 over 150 kilo ohms plus 1 over 41 kilo ohms, and that would be equal to 10.1 kilo ohms. Okay, we have the Rn tot. And for our BE, we have the R2 VE, so R2 over R1 plus R2. So, times si VCC minus BB natin. Okay? So siya kay 51 kilo ohms times 18 kilo ohms plus 51 kilo ohms times yung BCC natin na 10 minus 0.7. So, sagot din is 6.69 volts. Okay? So, again. Ang sunod natin kukuhanin. Kuhanin tayo ng IE. So, yung IE natin, VE over RE, we have 6.69 volts over RE natin, which is 470 ohms. And that will be equal to 14.2 milliampere. And we will have a RE prime of 25 MB over 14.2 milliampere. And this will be equal to 1.76 ohms. And for our voltage gain, so yung RE natin, 235 over RE prime natin, 1.76 plus RE uli natin na 235. And that would be equal to 0.992. And alam na natin siya na approximately to 1 siya. Okay? So, ipitan tayo sa page, pero konti na lang siya. Sige, dito na lang para magsama. So, yung IE natin, so VE over RE. So, yung VE natin, wala tayong VE. So, yung VE natin equals kay, di ba siya ang VE natin, AV natin, voltage gain natin equals kay, VE over VB kasi 'di ba output over input. So therefore yung VE natin ay pwede siyang ABBB. So, yung ABBB over RE, so, proximity to 1 times BB natin is, meron ba tayong BB? Ito, meron tayong BB, which is 3 volts. Yan. Over yung RE natin is 235. Yung IE natin is equal to 3 over 235 is 12.7 milliamperes. Yan. So, for IN naman natin, so, formula natin is VN over RN tot. So, 3 over Rin tot natin is 10.01 kilo ohms. So, ang input current natin is 297 microamperes siya. Therefore, yung ating current gain, so, nakakuha na tayo ng Rn base, Rn tot, voltage gain, current gain, and power gain. Okay, so, current gain natin is IE over IN is 12.7 milliamperes over 297 microamperes. So, yung AI natin would be equal to 42.8. Okay, so we have the IE, bilogan na nga lang natin, box natin. Mahalagang detalye. So, voltage gain which is equal to 1 RE prime. Yeah. So, Rn tot 10.0. And the power gain natin is approximately equal to 1, which is 42.8. Okay, so total power gain would be 42.8 since 1/2 yung RL, yung 470 1/2. So, divide natin sa 2 or times 1/2. So, this would be 21.4. Ito yung total power gain. Okay, so yan po yung ating for common collector amplifier. Okay? So, I hope na nasundan natin. Sundan natin. Pwede nyo palibalik-balik itong video para mas maunawaan natin. Okay? So, punta lang tayo before tayo pumunta sa common base, so, pahapyawan na natin itong mga special pairs. So, Darlington pair. So, for our Darlington pair, we have ito yung ganitong itsura. So, ganito yung itsura ng Darlington pair. So, yung emitter nung una na transistor ay nakakonect kay base nung pangalawang transistor. So, ibig sabihin, mataas yung beta nito. Bakit? Kasi, dalawa yung beta natin. Okay? So, madaming beta. Pumultiply yan siya, So, ibig sabihin, yung IE, so, we have IB. So, di ba yung IE equals sa beta IB. Meron na tayong beta AC. Tapos, yung IE ng pangalawa na tumaas na, ay siya na yung naging input itong pangalawa, which is yung IE1, yun na parang magiging IB nitong pangalawang transistor na i-multiply pa rin natin sa isa pa rin beta. So, kaya sobrang laki nung IE2 natin. So, one way daw to boost input resistance is to use Darlington pair para ma-boost natin yung input resistance natin. So, yan lang yung mahalaga natin kailangan malaman sa Darlington pair. Okay, so yung Rin natin, magiging Rin natin is beta AC1, beta AC2 times Ra. So, ilalagdag na lang natin si Ra prime. Okay? So, example natin, yan. So, mayroon tayong Q1 and Q2. So, itong medyo mahaba na, no? So, itong Darlington pair ay yung example, sagutan natin sa next video. So, kasama natin si Ziklai and the common base. So, next video natin. Okay? Para hindi masyadong mahaba. Okay? Bye! See you next video.